Now let's see this structural dependency. So structural dependency mainly occurs because one or more phases of the pipeline will try to use the same resources. So let's take this example. Assume that we have a 4-stage pipeline and every stage is going to have its own operation. So here first stage is about instruction fetch. So this is the logic which is required by instruction fetch, and the registers which are required are nothing but one is this program counter, because we are going to fetch the instruction pointed by the program counter, and after fetching it we are going to load it into IR. That is why these two registers we are keeping it with that phase. Okay, and after that we are supposed to read the data. So that is why this is the data read logic, and this is the second stage. In this stage the required operands are going to be loaded. So this stage is operand load, and the next stage is ALU. So here all the ALU operations are going to take place. So again we have ALU logic here, and the next stage is operand store, which is going to store the result into the memory. For example, if you try to perform A equal to B plus C, then we are supposed to load B and C into the registers, and later we are supposed to store the result into A, right? So what is the problem with such a organization is, it is very clear here. Okay, so see this. Assume that one instruction is currently being executed. For the first instruction there will be no problem. First instruction fetch will be, and operand load will be there, and then the next one is ALU, let's say it is execution, and the next one is operand store. They are the 4 stages. And the next instruction, while the first instruction is in this phase of operand load, the next instruction will start with instruction fetch here, and then operand load will be here, and execute will be here, and then operand store is supposed to be here if everything goes on well. But the problem is, if you observe instruction fetch, we need the access of the bus and the access to the memory. If you have only one particular memory, then what happens is, say this, if you have only one memory, then what happens is, let's not call it a memory, let's call it cache. So you know cache, right? We have already discussed about it, cache, and cache will be communicating with the memory. So memory is somewhere here. So we are going to load the program into cache, and then from cache we'll be reading it. Okay, now let's see this. So instruction fetch. So in order to fetch the instruction, we need to access the cache, and then in order to load the data, we need to access cache again. At the same time, when instruction I1 is loading the data, at the same time instruction I2 will also try to load the instruction, which means both these phases, operand load and instruction fetch, in this case are trying to use the same resource, but only one of them can use. So this type of dependencies are called as structural dependencies. So structural dependencies will occur mainly because of resource restrictions, which means one or more phases, two or more phases are trying to access the same resource, but we don't have the same resource. That is the reason. So one particular solution for this one is the only way to solve this structural structural dependency is resource replication or duplication. Resource duplication. So resource duplication means, instead of having only one resource, you try to have multiple copies of the resources, so that every stage will have its own copy. So in this case, how does this method work is, we are going to divide this cache into two parts. One part, let's call it as instruction cache, and the other one data cache. Now by having these two parts, when one stage is actually fetching the instruction, other phase will be able to load the operands. But even then, sometimes we may not be able to, in this particular case, even by using two caches, yes, we are able to resolve this conflict, but then we will not be able to resolve all the conflicts. Let's see where the other conflict will arise. See this. So these two instructions, there is no problem. If you want to see, you can check it. Only here there was a problem and it is being resolved, and here only one stage needs the cache, and here also during this time cycle, let's say this is time cycle 1, this is T2, this is T3, this is T4, this is T5. During T3 only one instruction needs cache, and during T4 only one instruction needs cache in here, right? And during T5 only one instruction needs cache. So as of now it seems like there is no problem. Now let's start the next instruction also and see if there is any problem. Instruction fetch is here, operand load is here, execution is here, and then operand store is here, right? So let's see if there is any problem here. Can you check this? So one is loading the operand here, I3 is loading the operand, and I1 is trying to store the operand, and both are actually trying to access the same cache, which is D cache, isn't it? Here again they are trying to use the same cache, therefore again there is a conflict, and this conflict also has to be resolved. Got it? So how can we resolve it? Actually we cannot even modify it in such a way that both are having different caches. So only way we can do it is to change the entire pipeline stages. So we'll now see how this problem has been eliminated, or how it has been handled by a practical microprocessor. We shall see what is it using and how it has resolved it. So in this example, what you should learn is, one of the ways that we will get structural dependency is because of the memory, right? And we can split the memory, and to some extent we can resolve the conflict, but all the conflicts cannot be resolved. But later we shall see how to rearrange the stages in such a way that this conflict can be resolved. And the second thing is, it is not always the memory which is leading to the structural dependency, as it is in this case. But then apart from memory, there will be other resources also which will cause the structural dependencies. For example, in this case, this is a register file. This is a register file. So if you see this, data read logic is reading the data into the register file, and then that particular register file is being accessed by ALU, and again that ALU is writing the result into the register file, and while writing the result into the cache, we are again accessing the register file. Therefore, the register file is being shared by all these three resources, and so you should have some kind of provision so that two registers or three registers can be accessed at the same time. Let us say while reading you will be using some register, and while operating something. So anyway, what we should have is some provision by which the registers can be shared without any problem. For example, if you have only one data bus which is used to transfer the data, then it will obviously be a problem, because when this particular stage is loading the data, if this particular stage is also trying to write the data, and if you have only one data bus, it will not be possible, right? So therefore, in practice, there are various reasons why we can get the resource conflicts, and all of them are going to cause the structural dependencies, and most of the structural dependencies can be resolved by using resource duplication, and some of them will be resolved by rearranging the stages or combining various stages. So we are going to now see a very good example of a microprocessor which has actually combined these two stages and has limited the access to memory to only one stage. So how it is doing that, we'll see it now. Okay, so this is about this. We shall get into the example and see this one. So I'll erase it and again draw the next one. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.